This is fluid coding and AI. Mastra just made a very specific promise. Claude Code, Cursor, and Codex-style agents can sit behind one TypeScript supervisor. That sounds like agent portability. The real question is sharper. Can one harness make different coding agents observable and comparable, or does every agent still bring its own state, permissions, costs, and review workflow? On June 15, 2026, Mastra announced SDK Subagents for Claude Code, Cursor, and OpenAI-style agents. The important phrase is not just model agnostic. Mastra frames this as harness agnostic. Instead of treating every coding agent as a separate product silo, Mastra lets you register provider SDK agents inside the same Mastra application, then call them through familiar agent methods like generate, stream, resume generate, and resume stream. That is the new surface area, not only which model answers, but which agent loop runs the work. The honest version of the feature is more interesting than the hype version. Mastra's docs say the provider SDK keeps its own runtime, tools, permissions, and agent loop. Mastra wraps that agent so your application can use a common call surface and common observability hooks. So the wrapper is not pretending Claude, Cursor, and OpenAI agents behave the same way. It is giving you one place to invoke them, stream them, and inspect them. That distinction matters when the output is a real code patch. Coding agents are moving from editor chat into programmable infrastructure. A team does not just want an agent to say it fixed a bug. They want the same repository snapshot, the same time budget, the same allowed tools, and the same acceptance tests. They also want streaming progress in one interface, because long-running agent work can otherwise become a black box. If the final result is a pull request, the human reviewer needs a compact comparison, changed files, commands run, tests passed, risky actions, trace links, token usage, and cost. The supervisor pattern starts with one repo task. For example, find why auth refresh fails, implement the smallest fix, add a regression test, and summarize the patch. Then the workflow fans that task out to 3 lanes: a Claude SDK agent, a Cursor SDK agent, and an OpenAI agent. Each lane should get an isolated checkout, the same starting commit, the same task instructions, and the same task command. Without that isolation, you are not comparing agents. You are comparing whatever state happened to leak between them. The seductive part is the registry. Mastra can register a Claude SDK agent, a Cursor SDK agent, and an OpenAI SDK agent inside one Mastra instance. From the application side, those agents can be called by ID. That makes routing simple. A workflow step can choose a lane, stream its output, and record the run under a shared task ID. But a registry is not a physics engine. It does not make file system access, sandboxing, approval prompts, or session continuation identical. Streaming is where the supervisor starts to feel useful. Mastra says SDK subagents inherit its stream composition APIs. The docs also show registered SDK agents streaming chunks back through Mastra. For a coding supervisor, that means each lane can publish progress into one interface: current status, latest text, current tool, files touched, test output, and any token or cost counters the provider exposes. The viewer is no longer trapped inside 3 separate chat transcripts. The work becomes a set of comparable lanes. Observability is the reason this becomes more than a convenience wrapper. Mastra observability covers agent runs, workflow steps, tool calls, and model interactions. Its docs describe 3 signals: traces, logs, and metrics. Traces give the span tree. Logs correlate back to those traces. Metrics can include duration, token usage by type, and estimated model call cost. That lets a platform team ask better questions: which lane stalled, which tool call failed, which model interaction got expensive, and which patch actually survived the test command. Mastra Studio is part of the story because it gives developers a place to test agents, run workflows, and inspect traces. The workflow docs describe structured steps, branching, parallel execution, suspension, resumption, and streaming results. For a multi-agent coding task, that means the supervisor does not have to be one giant instruction blob. It can be a controlled workflow: prepare the repo, launch the lanes, stream events, run tests, collect diffs, score the patches, and produce a review summary. That is infrastructure, not just chat. The eval layer should not crown a winner from vibes. Mastra's current eval surface is scorers. They can be model-graded, rule-based, or statistical, and they can run in CI across multiple test cases. For coding agents, the first score is still boring and deterministic. Did the test pass? After that, scorers can help judge patch minimality, explanation quality, security risk, and human review burden. The final comparison should rank patches, not personalities. SDK subagents are not the only adapter path. Mastra also supports Agent Client Protocol through a package that can run ACP-compatible coding agents as tools or as subagents. The docs name Claude Code, AMP, Codex, and any executable that implements ACP over standard input and output. A2A is a different shape. Mastra's A2A support is about delegating across frameworks, vendors, languages, and remote agents with declared capabilities. ACP fits editor-style coding agents. A2A fits federated delegation. They should not be blurred into one generic protocol story. This is where the common interface leaks, and the leaks are not edge cases. Resume behavior is provider native. Claude resumes by session ID. OpenAI resumes through previous response, conversation, or session data. Cursor resumes through its wrapped SDK agent or agent ID. Structured output is uneven too. Mastra's docs say Claude and OpenAI SDK agents can use provider-native structured output, while Cursor throws a clear error because its TypeScript SDK does not expose schema-constrained output. That is exactly why the supervisor needs explicit capability checks. Permissions are the risk surface that deserves the most scrutiny. Claude, Cursor, OpenAI sandbox agents, ACP agents, and A2A agents can all imply different file access, shell access, approval, and workspace models. Mastra's ACP docs include a particularly important default. ACP agents may request permissions, and unless customized, the wrapper selects the first option returned by the agent. That might be fine in a demo. In a production supervisor, permission policy should be explicit, conservative, and recorded in the trace. Cost comparison also needs care. Mastra can surface logs, traces, token usage, and model cost in Studio. The SDK agent docs say the available usage and cost details depend on what each provider SDK exposes. Claude runs can include SDK estimated cost. Cursor runs include token usage from interaction updates. OpenAI runs include token usage from OpenAI run state. So the comparison screen should show the source of each cost field, not just a single leaderboard number. And Mastra metrics require an OLAP-capable observability store, not any arbitrary database. There is no first-party benchmark in the research showing these June 2026 SDK subagents beating each other on the same coding task. The relevant benchmark evidence is from Mastra's memory research, and it should stay scoped that way. Those reports show that context strategy, timestamps, formatting, model choice, and retrieval depth can change long memory results dramatically. The lesson for coding agents is not that one subagent wins. The lesson is that setup matters, and a serious comparison needs the task instructions, commit, tools, trace, tests, failures, and caveats attached. Here is the practical verdict. Mastra's SDK subagents make a TypeScript supervisor much more plausible. They give you one place to register coding agents, stream progress, orchestrate workflows, attach traces, surface token and cost data, and run evals over the final patches. But they do not make Claude, Cursor, OpenAI, ACP, and A2A agents equivalent. The right mental model is harness for harnesses. Use it to compare agents with receipts. Do not use it to pretend the receipts are all the same. If you want more practical breakdowns of AI coding agents, evals, and developer infrastructure, like this video and subscribe to Fluid Coding and AI.